Assalamualaikum. My name is Nur Atira binti Othman and my metric number is E24A3501. Today I'm going to tell you guys about the answer for question 1, 2 and 3. Question 1. Define what multiply linear regression is. So what is multiply linear regression? Multiply linear regression is a statistical technique used to examine the relationship between one dependent variable and two or more independent variables. It helps in predicting the value of the dependent variable based on the value of the independent variable. Also, it shows how strong each predictor influences the dependent variable. Next slide. Question 2. Determine what is dependent and independent variable are for the case study given. So from analysis that we have done using Spss apps, we found that dependent variable is groundwater while the independent variable is temperature, vegetation, and rainfall. Next. Question 3. Write the regression equation. So the regression equation is groundwater plus vegetation plus rainfall and minus temperature. So we have to know each value of it. So first of all, groundwater is 0.419. Have to plus vegetation, which is 0.016, and plus rainfall, which is 0.003, and we have to minus with temperature, which is 0.016. And the answer of the total of this equation is 0.422. That's all.
Question 4. This question asks us to check if the model we use is significant or not. From the model summary table, we can see that the R2 value is 0.971. This means that about 97.1% of the change in groundwater recharge rate can be explained by the rainfall, vegetation cover, and also the temperature. That's a very high percentage which tells us that the model fit the data very well. To check if the model is significant, we usually do a global hypothesis test. Simply put, the null hypothesis says that all the predictors have no effect, and also the alternative hypothesis says at least one of them does. Since our R2 is so high, we can confidently say that the model is significant and the predictors do help explain the change in the groundwater recharge rate.
For question 5, We need to test whether the whole regression model is significant. This means we are testing null hypothesis and alternative hypothesis. From the ANOVA table, we got F value equal to 179.052 and the P value equals to 0.001. Since the P value is less than 0.05, we reject the null hypothesis. This means the model is statistically significant.
Assalamualaikum everyone. My name is Siti Nokshika binti Abu Bakar. Today I will be presenting question C, which requires us to conduct individual hypothesis tests to determine whether any of the independent variables can be removed from the regression model. There are three independent variables involved in this analysis, which is vegetation, rainfall, and population. So before we begin, let's start the hypothesis test. The new hypothesis states that the variable does not significantly affect the groundwater recharge rate. The alternative hypothesis states that the variable does significantly affect the groundwater recharge rate. Now, let's look at the p-value for each variable. First, for vegetation, the p-value is 0.000. Since the value is less than 0.05, it means vegetation is statistically significant. So, vegetation should be retained in the model. Next, we have rainfall, which also has a p-value of 0.000. Again, D is less than 0.05, meaning rainfall is also statistically significant. Therefore, rainfall should also be retained in the model. Finally, we look at population, which has a p-value of 0.778. This value is much greater than 0.05, which means population is not statistically significant. As a result, population can be removed from the model. In conclusion, vegetation and rainfall are both significant and should remain in the model, while population is not significant and can be excluded. That is all for my presentation. Thank you.
Assalamualaikum and good morning. For question 7, we were asked to predict the groundwater recharge rate using the multiple linear regression model that we obtained earlier based on the Spss analysis. The given value that we were given is for vegetation cover equals 162, average month rainfall 535, average temperature 21.5. The regression model we obtained from the Spss output is y equals 0.14919 plus 0.016 multiplied vegetation plus 0.663 multiplied rainfall minus 0.016 multiplied temperature. We substitute the value into the formula. 0.1419 plus 0.016 multiplied 162 plus 0.003 multiplied 535 minus 0.016 multiplied to 1.5. We calculate each part. 0.019 multiplied 162 multiplied 2.59 0.003 multiplied 535 equal 1.50. 0.016 multiplied to 1.5 multiplied equal 0.34. The last result we got when we calculate, we got y equal 4.27. Therefore, the predict groundwater recharge rate is approximately 4.27 millimeter per year when vegetation cover is 162 hectare, rainfall is 535 millimeter and temperature is 12.5 degrees Celsius. In conclusion, the model suggests that higher vegetation and rainfall increase the recharge rate while temperature is a slight negative effect. Thank you.